Hello guys, so we are going to continue our discussion with respect to Python, and in this video we are going to discuss about inheritance in Python. Now this inheritance is a fundamental concept in object-oriented programming that allows a class to inherit attributes and methods from another class. Right? So in this specific video, I will be talking about how you can implement inheritance with the help of Python. We'll be discussing about single inheritance and multiple inheritance, and I'll be showing you multiple examples. So let's go ahead and let's see. Now, inheritance is basically derived from the real world scenario, guys. I hope, like let's say you will be inheriting your parents' property. It may be house, it may be land, but the vice versa will not be possible. Your parent will basically not be inheriting your property, but instead it will be going to your children, right? So this kind of scenario, so this is based on the real world scenario, and similarly, the inheritance property in Python also works in the same way, okay? So let me just go ahead and show you one specific example of inheritance, and then I will show you how you can probably create a child class and probably inherit the parent class altogether, right? So I will first of all start defining my parent class, okay? Now here, let me just go ahead and define one class which is called as car, okay? Now car is my class, okay? So I can also go ahead and write like this, okay? Class car. Now, first of all, as you all know, whenever we define a class, we need to probably create a constructor. So let's go ahead and create this underscore init underscore, and here I'm going to use one parameter, that is self, and the other parameters that we are going to provide while we are instantiating the object of the car class, like windows, doors, right, engine type. So let's consider that these are some of the attributes that we are going to pass. And let's go ahead and create some of the instance variables. So I will go ahead and write self dot, and the first thing is that windows, right? I will go ahead and create the first attribute, that is windows, and I'll assign this value to the windows that I'm passing over here in this init method, okay? Then we will go ahead and write self dot doors, okay, where I will be passing the doors value, and finally I will go ahead and write self dot engine type, okay, engine type. And again, I've already told you, it need not be, this name need not be same as this. You can write anything over here, but these are the attributes or instance variable, right? So is equal to, we will go ahead and write engine type, okay? Now this is my car class, and this is what I have in terms of attributes and all. Let me just go ahead and define one instance method also. Let's say with the help of car, we usually drive. So here what I'm actually going to do is that I'll go ahead and use self keyword, okay? And let me just go ahead and print, okay? And let me say that the person will drive the car. The person will drive the which car, okay? So let's say that the person will drive the petrol car or engine type car, right? So here I will just go ahead and write engine type, okay? And here I'm actually going to use this f string, okay? Engine type. Now engine type, I cannot directly use it over here because I have to use self dot, right? Because engine type is an attribute over here, right? So the person will drive the engine type car, okay? And I have to probably, if I want to use this attribute over here, I have to use self dot, okay? So inside this is my parent class, okay? I've defined a class with an init method. The attributes are windows, doors, and engine type, and one instance method which is called as drive. And here I'm saying that, hey, the person will drive whether it can be a petrol car or diesel car based on the values that we provide, right? Now, once I probably go ahead and create this class, let's consider this is my parent class. Now I can go ahead and write car1 is equal to, I will go ahead and define my car, okay? And here I'm going to give the values. Let's say the number of windows are 4, number of doors are 5, and let's consider the engine type is petrol, okay? Petrol car, okay? And now I will go ahead and print car1 dot the method that is drive, right? Now if I go ahead and execute it, here you'll be able to see that, hey, the person will drive the petrol car, and obviously drive does not return anything over here, so that is the reason it is giving you none, okay? But in short, over here you can see that I'm just writing car1 dot drive, so it is just going to display this, the person will drive the car, okay? Perfect. If I just remove the print method, then you will be able to see that I'll be able to get only one message, okay? That is print, the person will drive the petrol car, because this drive method is not returning anything. But this is fine, right? This is very much easy, and here you can actually see that what all things we have basically done, right? We have given a car class, and probably we have defined the init method, we have defined method over here, right? And we are able to create the objects, right? This is perfect. Now let me do one thing. Now, see, there are different types of cars, right? I can just consider this car class is a blueprint of a car object, right? This is the blueprint where it has this many number of attributes, this many number of methods. Now let me just go ahead and create one class which is called as Tesla. Okay. Now this Tesla car that you are probably seeing over here, obviously it needs to inherit from the car blueprint itself, right? Because in this Tesla also, I will be having windows, I will be having doors, I will be having engine type, right? And there may be some additional feature that may be available in Tesla. So I don't have to again go ahead and define this entire thing. Instead, what I can do, I can just inherit this car class and I can inherit this properties along with I can inherit this functions or methods, right? Because I don't have to recreate the entire class completely from scratch. If it is inheriting this particular car class, which is a blueprint, it will be able to inherit all these attributes and methods, right? So let's go ahead and do this. So in order to make Tesla inherit car, so I will just go ahead and write over here as car. So this is how you basically write. First of all, you really need to write your child class like class Tesla. And then whatever things you basically write in the bracket, this is basically inheriting that particular class. Okay. Now we will again go ahead with defining our init function, because here also we'll be having an init function, right? So definition underscore underscore init underscore underscore. So this is my constructor inside the Tesla. And you know, here also we require attributes like windows, doors. Okay. So we need to pass it during the runtime. Then you have engine type. And finally, these all attributes are already available over here, right? So there may be additional attributes that may be available in Tesla. So I will just go ahead and say is self-driving. Okay. And this will be a Boolean value. Let's consider this. Okay. Is self-driving. So Tesla, you know that it has the self-driving functionalities. Okay. Now, fine. Now, the main thing is that I need to create the attributes for windows, doors, and engine type. And I know that car already has this kind of attributes, right? So I don't need to go ahead and write self dot, right? What I can do is that I can just use this super keyword, right? If I use this super keyword, that basically means I'm saying, hey, I am trying to call super basically means I'm just trying to call the parent class over here. And from the parent class, I will just go ahead and call my init method. Okay. So here, what does super underscore init basically mean? That basically means that we are just calling this init method from the car class, right? Parent class, right? And that is the reason we are just writing super dot underscore underscore init. Now, over here, the next step will be that you know what all attributes I'll be getting from the parent class. One is windows. Okay. So let me just go ahead and write windows, doors, and then you have this engine type, right? Then you have this engine type. So this three values or attributes I should be getting from this car class, right? So I don't have to again define it. But what about my is self-driving? So I will just go ahead and write self dot is self-driving. Okay. So let me just go ahead and create this variable self dot is self-driving. Oops. Self dot is self-driving. And I will assign it to is dot self-driving. So this is the attribute, and this only attribute we'll try to create inside the Tesla class. Okay. And remaining all, we are in short inheriting from the parent class, right? Now, when we are inheriting this, obviously it is true that we'll also be able to inherit this too, right? So let's see this. Okay. Now I will go ahead and probably I've created my init method over here. And now what I will do, I will create another function which supports self-driving, right? Let's say self-driving. So here I'm just going to write self-driving. And here I'm going to say self. Okay. Perfect. Right. So this is the method, or this is the instance method that we are going to create inside this Tesla class, which is the additional thing when compared to the class blueprint, car blueprint. Sorry. Now here I'm just going to print something and write over here Tesla supports. Okay. I can just go ahead and write self dot is. So here I'm just going to use my F string. Always focus on using this F string, then only you'll be able to use this particular, you'll be able to basically write in this way. So self dot is driving. Okay. So here you have this entire thing. Okay. Now set Tesla supports self-driving, true or not. Tesla supports self-driving. So here I'll say self-driving. So this will basically give me a value like true or false. Okay. Now this is my entire Tesla car, right? And this is my child class, which is inheriting the car class, right? Now once I execute this, now let's go ahead and call this. Okay. So first of all, I will just go ahead and write Tesla 1 variant, and I will go ahead and initialize it. And now what all parameters I need to give? Windows, doors, and engine type. So I'll say, hey, windows are 4, doors are 5, engine type is electric, let's say electric. Okay. And whether it supports self-driving or not, I'll just go ahead and write true. Okay. Now after giving all these parameters, you'll be able to see that if I go ahead and print Tesla 1 dot self-driving, okay, and I'll call this function. Let's see what it says. So here you will be able to see that it is printing Tesla supports self-driving is equal to true. And this is what we have given. So what happens once we call this particular child class with Tesla and all these values? What it is going to do, it will just go ahead and call super init, and it will pass all these parameters over here. And this init will make sure that all the attributes it will go ahead and initialize with those values like self.windows, doors, and engine type. Now once that is done, then we'll go ahead and initialize the attribute is underscore self-driving, which will be assigned to true. And then I can probably call this particular function. Not only this, now in the parent class, I have this drive function, right? So I can also call that. See, I will go ahead and write Tesla 1 dot drive function. Okay. If I go ahead and call this, here you can see the person will drive the electric car, right? And this is how you can probably see that a single inheritance works like, right? And you understood the main mechanism. If you really want to inherit any parent class, how you have to probably use this init method, how you have to call this super init method, how to define the new attributes, how to initialize those new attributes over here, during the runtime. And along with that, you can actually go ahead and create any more methods that you want. Okay. And this is what is an example with respect to inheritance. And this inheritance, I will just say it as single inheritance because only one child class is inheriting the parent class. Okay. Now let me just show you an example with respect to multiple inheritance, but I hope you are able to understand. Okay. So here will be multiple inheritance. Okay. Now multiple inheritance means what? When a class inherits from more than one base class. Okay. When a class inherits more than one base class. Okay. Now what does this basically mean? Let's go ahead and create one base class. Okay. Let's say I will go ahead and create animal. Okay. So animal is one class. Okay. And here I'm just going to use my init method. And here, let me just go ahead and write self comma name. Name is what I'm going to pass as an attribute. And I will go ahead and create my attribute self.name is equal to name, right? So this becomes my animal class. Okay. An animal class, let me just go ahead and create one function, which will be like speak. Okay. And here I'm going to use self. And let me just go ahead and probably, print something. So here I'll just go ahead and print. Okay. Subclasses must implement this method. Let's say I'm just going to write this. Okay. Now this is done with respect to my class, right? Now what I will do is that I will go ahead and create another base class. So this is one of my base class. So here I'll write base class 1. Okay. Base class 1, because see when a class inherits from more than one base class. So this is my base class 1. Now let me just go ahead and create my base class 2. So base class 2. Okay. And here I'm just going to copy this, and here you can see I have this pet class and I'm creating this init method with self comma owner, and I'm saying, hey, self.owner is equal to owner. Okay. Now let's go ahead and create my derived class. Now derived class will be something like inheriting both these classes. Now in order to for a child class to inherit both this class, I will go ahead and create class dog. Okay. And this time, in order to inherit both the classes, I will go ahead and write animal comma pet. Okay. So this is how you basically give in comma separated inside these brackets. Then what I will do, from animal I will be taking this name attribute. I will be accessing this speak. Along with this, from pet, I will be getting owner, right? So here, if I want to use this owner attribute and name, all I have to basically go ahead and write. I'll go ahead and create my init method. Okay. And here I'm going to give self comma name comma owner, right? And here, let me just go ahead and write animal dot underscore init. Okay. So this is also another way of probably calling it, right? Let's say I want to get the attribute of name from animal, right? So this name is basically present in animal. So instead of just writing super dot, I can just write the class name dot init, and here I can actually give self comma name. Okay. So this is one way. The other way is that, again, I will go ahead and do it for the other class, pet underscore init underscore, and here also I'll go ahead and write self comma owner. Okay. Self comma owner. See, what is the difference between before the methods that I have discussed? Here I have used super because I just had one parent class. But since here I have two parent class, like base class 1 and base class 2, right? I need to use one attribute from this particular attribute itself, from this particular class animal, and one more from this another base class. So what I'm doing, I'm just writing animal dot underscore init. I'm calling the animal init method, and there I'm passing this particular parameter, and then I'm calling pet underscore init, and then I'm passing the parameter over there. And when it goes to this init method, then this attribute gets the value of this, right? This is how the entire flow goes. Now, finally, let me just go ahead and create a speak method. So I'll just go ahead and write a definition speak, and here I'll go ahead and say it is a self. Now, let me just go ahead and return. So return will be an F string, and let's say here I'm going to basically write self dot name says hoof. Okay. Self dot name says hoof. Okay. And this is what is basically getting printed. So let me just go ahead and write a return over here. Okay. Now it should be working fine. Now let's see this, how this will work. Now we'll go ahead and create an object. Okay. Create an object just to see that whether it is working fine or not. So here, first of all, I'll go ahead and call dog is equal to, I will initialize from dog. Here I'm just going to write the name will be buddy and the owner belongs to Krish. Okay, let's say. Then I will go ahead and print dog.speak, and if I go ahead and execute this, you'll be able to see that I'll be getting buddy says hoof. See, there is also a speak method over here, but since we are directly calling it from the dog class, so this speak method will be given more priority when compared to the parent class, right? So that is the reason it is saying buddy says hoof. Okay, then I will just go ahead and print my f owner. Owner will be nothing but it will be self dot, dog dot owner, right? Dog dot owner. Okay, so let me just go ahead and execute it. So here you will be able to see that owner is nothing but Krish and buddy says hoof. So here what we are doing, here we are creating two parent class, two separate base class. Okay, and we are inheriting them from a derived class, and this is basically called as multiple inheritance. Okay, or we can also say it as multiple inheritance. Yes. Now let's do one thing. Let's create an amazing use case, and this use case will be about modeling a complete library system. That we'll discuss in our next video, where we'll be modeling a complete library system. Here there will be using single and multiple inheritance. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Thank you. Take care.